Okay. Yes, it's going to be an ellipse, and then once you rotate it, it's going to be an ellipsoid. But which type? Well, we'll have to see. Does anybody remember the two types of ellipsoids possible?
Shoot, I wrote it down.
Hyperbola.
There was.
Okay, do I need to actually sit in front of you guys? I didn't know I had to do this for you guys.
The
Okay.
late and the oblate.
Yeah.
Prolate and oblate. Prolate, you rotate around which axis? Major. Pro, major, pro. That should kind of go together. So, prolate goes around the major axis, then oblate or oblate. Oblate? Oblate? Goes around which axis? Minor. Okay? So let's figure out which way we're going. This one, we know that we're going about the y-axis. We can go ahead and right now show the little rotation arrow. Yes, that's worth a point on these types of problems. If you just show me, hey, I'm going around him, but we still have to get this guy. How can we graph this guy? Plug in 0, 0, 1, 1, 2, 2 and figure out points.
Divided by 16.
The best way would be to go ahead and get it in the ellipse equation, right? And the ellipse equation says divide everybody by 16. I end up, when I put 4 over 16, I get 1 over 4. When I put y squared over 16, well, that just kind of stays. And then 16 over 16 is 1. Okay. How do we make an ellipse? How do we use these numbers?
4 is the.
2 squared.
We can think of 4 as being 2 squared.
So.
Not that you have to write it per se. 16 is 4 squared. So we're going to use 2 and we're going to use 4. The center is 0, 0, because it's like x minus h, y minus k. It's like I have a 0, 0 in there. How far to the right and to the left am I going to go for this ellipse? 2. How come? Yeah, because the 4 is underneath the x term, or the 2 squared is underneath the x term. So 2 is the measurement horizontally, then I'm going to go right and left. If you want, you could put little like rotations and say, okay, I'm going there and there. How far up and down am I going as dictated by the y squared term? So I'm going to go y up, 4 up, the y, 2, 3, 4. 4 down the y, 1 and a 2 and a 3 and a 4. Okay. So this is a vertically oriented ellipse, right? Okay. So with our vertically oriented ellipse, which is that's a little messy, but it's the right idea. If we spin a vertically oriented ellipse around its vertical axis, is that around its major or around its minor? Around its major. So what type of ellipsoid should this make? A prolate, because it's around the major. If you think about the spin, shouldn't you be able to show me that prolate? You want to show me more rotations if you really want? You don't have to, but you can. Artistic ones, if you want to show the spin. You can have all sorts of fun with it. You can have it going really fast. But anyway, long story short, I guess it couldn't be this way, wouldn't it? But anyway, prolate ellipsoid, done. Questions on number 4. Get the ellipse, spin it.
I know.
Well, the ellipse is a little bit easier than the hyperbolas. Hyperbolas, you have the like asymptotes and the vertices and all that. But we're kind of like, we're reviewing how to graph ellipses and hyperbolas and stuff, right? And that would be from sections 10.2. Let's see, this one would have been 10.3. Parabolas were 10.2. Ellipses were 10.3. Hyperbolas 10.4. Number 10 is not going to be too bad because all you're graphing on that one is what? Wait, y equals mx? Hopefully not. That's algebra 1. It's almost pre-algebra. What are you graphing?
A line.
A line. Right? Mx plus b. What's my y-intercept, guys? 0, 0, because b is 0. And what's my slope? Up 1 over 2. Up 1 over 2, right? Up 1, down 2. The hyperbolas are complicated. The line wasn't supposed to be super crazy. Wait a minute. What's this whole, remember we talked about this in class on Friday? What do I do with that -6 to 6 thing? Yeah, I go that far. So far I have what? I've gone over to 2, 1, over to 4, 2, so I need to go 2 more to make it the 6, or the positive 6. So I'll go over 2 more, no big deal, yeah. I gotta extend a little bit more. So I can have 3, 3. No, 6, 3, sorry, my apologies. 6, 3. And then I just need to go -6 as well. So I've gone over +6 on this side, I'll go over -6 on the other side. Let me go a little bit faster. 1, 2, 3, 4, 5, 6. So we're gonna go left 2 down 1, left 2 down 1, left 2 down 1, approximately. Remember, in order to spin these, we have to have some sort of finite distance. We don't want it to go infinite. And then where are we spinning it around? You'll get a point for this. How do you show it to me? Arrow around the x-axis. I'm going to go ahead and throw that rotation arrow right here. And then as you're rotating, kiddos, just imagine this right side. We did an example like this on Friday. If you spin a line, what do you get? And they even gave you a hint in the wording. You get a cone, and it's going to spin this way because it's around. Think of it coming around the x-axis. Pull this off the paper in a sense and be like, hey, you're going around. Okay, cool, I'll show that somewhat artistically, not entirely, but we'll pretend. But going around, if you want, you can go ahead and kind of reflect that line just to show that. It's going to go around, and as it comes around, there's going to be a cone on that side. This one's going to spin as well. So you're going to have that reflect on the other side, roughly. There we go. Dun 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 dun. Just let it spin.
Spin.
Just let it spin. Right, as it spins, it's kind of like an hourglass-ish, but it comes to a point. So we just call it that double-nape cone if you want, like we did in the beginning of conic sections. Okay.
Oh,
What other ones of the graphing ones? So whatever problems you had 1 through 10, what other ones do you guys have questions on? 5. Was that a hyperbola one?
yeah.
Okay, that's good if it is, because the hyperbola, the rotating of hyperbolas get a little bit tricky. Okay, so we'll do number 5, and then we'll go ahead and look at those inscribed ones, okay? Get a new page here real fast, import below, nope, I don't want to import, sorry, add page below. Alright, what's the equation that we had for number 5, guys? 4 minus y squared equals what? Okay, and what are we rotating it around? Do they cut it off? Oh, they do, from x equals?
1 to x equals 2 about the y-axis.
Alright, let me go back to the notes real fast. Here we go. How do I start?
Change it to hyperbola.
The standard form, kind of like we do with the ellipse, and how do we do that with the ellipse? Do you remember?
Multiply it by 1/4.
So divide everything by 4. And when we divide everything by 4, we'll end up with, well, 4 over 4 will just be x squared, right? And if you want something, you can put over 1. So if I divide 4 on this side, I gotta divide 4 by everybody. So then I'm also gonna have a y squared over 4 equals 1. So now we need our axis. Center is 0, 0, because it's x minus 0, ultimately. See, x is 1, x is 2. Making the x's spread apart, because it just said x is 1 and x is 2, so I'm guessing we can go that way. I'm going to go ahead and pick a really light gray, just for the sake of, do I really want the asymptotes to be super messy while I go to rotate? No. So I'm going to go ahead and let's get some asymptotes in there. Let's go here first though. I need to, let's see, figure out my, that's not the same red. Probably no one else will get bugged by that one. Alright. X squared over 1 squared, y squared over 2 squared, just so we see where those numbers are coming from. And how do I get the slopes of my asymptotes? B over A, but just think about it, it's not that big a deal. Rise should go with what, the x or the y? Good, so rise, so 2 over 1, but I need plus or minus because the asymptotes go both ways, right? So it's the rise over the run, so the 2 over the 1. This is section 10-4, guys. So now I'm gonna go ahead and, let's see, we need some y values, and they better be a little bit closer together or I'm gonna be in some trouble. There we go, 1, 2, 3, 4, 6. Okay, question, hold on, before, I could do my asymptotes if you guys want me to. But we also need to figure out whether this hyperbola is going up, down, so vertically oriented or vertical transverse, or whether it's going right, left, or horizontal. What do you guys think based on the equation that we're given as I graph the asymptotes from the center? Why right, left? Since x is the first term. Good. Right, left, since x is the first term. There we go. And then, is that about right? So I could go ahead and have, there's one. I can draw my other one up to back one. This is for the negative 2/1. Up to back another one. Up to back another one, approximately. I was having too much fun. Okay. There are my asymptotes, roughly. This one down here probably should be a little bit steeper, but that's okay. Same idea. Okay, so if it is, how would you say again? Horizontally or vertically? Horizontally, because the x comes first. If it's horizontally oriented, where am I going to know how to start my branches of my hyperbola? Where are my vertices? Plus or minus 1, because look, if it's horizontal, look at his value below. Look at his, I can't call it a minor radius. The a underneath, that's being squared. So I'm going to go ahead and go right one to get a vertex. If it's horizontally oriented, left one. And remember, once again, that is totally dependent on who comes first, who's the positive term. Since the x term is the positive term, we know that we are going to go ahead and move it right, left. And then basically all I need to do is skim. But question, why am I stopping it here? Actually, hold on. Aren't I supposed to go over on this side and stop it over here? Yeah. Because they tell me just between 1 and 2. So there's x equals 1, there's x equals 2. But hold on, the hyperbola goes both up and down, right? So I have the up and down of the right branch. I have the entire right branch ready to go. However, guys, where am I rotating this right branch around? The y-axis. So if I'm rotating this around the y-axis, can you guys tell if it's going to be a 2 sheet or a 1 sheet? Why? Pull it off the paper, imagine this is a string and spin it. As this goes around, question, do they join together or do they stay separately contained? They join together, yeah. So therefore we could almost say, well hold on, he's just going to come across anyway, so why not just go ahead and graph him and say, okay, there's that one. Go ahead and get that branch. There's that one. All we got to do is say hourglass time.
How would the 2 sheet be?
A 2 sheet would be, in this specific example, if I have the sideways ones, if it's spinning around the horizontal instead, then I would have them just spinning in themselves. Does that make sense? So those are the 2 separate bowls, so they're spinning just around this way, staying self-contained, each of the branches self-contained. This one, the branches are joining, and they're making one solid figure. Let me get rid of that 2 sheet one, because that's not the example at hand. All right, kiddos, good questions on how to graph. The nice thing is we did get everything but a paraboloid, but hopefully parabolas are not quite as hard for you guys to graph as, for instance, the ellipses and the hyperbolas. And then we just have to learn how to spin them. Now, I did already say that on the test, when I test you on these types of rotations and the figures they form, I have gone ahead and given you the starting shape. Why is that a good thing? Yeah, you just need to figure out how to rotate them. Because some of you got stuck because you read the question, you're like, I don't know what to do with it, and you forgot, take this standard form and go ahead and put it in the clue form and use the equation clues like from 10-1, well, 10-2, 10-3, 10-4 in order to graph. Some of you got stuck on getting the original one, so how could you rotate it? On the test, I don't want that to happen, so I'll give you the original. And I won't even give like nasty equations and whatnot, I'll just say like, hey, go ahead and rotate this around this axis, this around that axis, and give me the name. Does that make sense?
Are you gonna show us the picture or just, you're gonna do like, okay,
So I'm gonna give you the original two-dimensional conic section, and I'll say spin it around this axis, whether it's the major or the minor or the transverse or the conjugate. You guys knew that last time. Alright, kiddos. These are like 11 and 13, 17 was just bonus. Okay, for 11 and 13, let me get the worksheet up real fast. He's here. The handout, what you were trying to work on. Yeah, same one. Because the homework just kept on going to 11 and then 13, and technically I circled 17, but I don't think it was online, so some people got confused. Guys, this one, number 11, triangle and parabola. Is this two-dimensional or three-dimensional? Two-dimensional. So it's a lot like the example that we did on Friday in our notes. This one. How we had a beginning parabola and how we were thinking of a rectangle underneath. We had to think about area being base times height and getting it in terms of x and y. All that's explained in the video on Friday. So number 11 is a lot like that one. Number 13 though, what was different about him?
Cylinder and a sphere.
Okay, so if it's a cylinder, isn't that like the one that sadly we didn't really get to? Sad times. So let me go ahead and work through with you guys number 14, see if that answers your questions about number 13. Because you guys have the answers to number 13, you don't need to see those answers from me, I think you need to see an example more than anything. So, for number 14, I was saying try the volume 1, well actually, hold on, I was saying try the volume 1, right? And see if you can get it right. Then we'll go ahead and do number 13, some of you guys are stressing about homework anyway. Let's go ahead and try number 13, sound good? I'm going to do a whole new page for it though. Tell me the stuff that you guys know from number 13.
we know the parabola, right? What is this?
That should be equations, come on guys. X squared plus y squared?
Yes.
What else? Equals 25. Okay, so I have an ellipse, right? If I want, I can write that all nice and pretty because it'd be x squared over, ooh, this isn't just an ellipse, isn't this a circle? Because they have the exact same dilation, they have the exact same A and B. So we could think of it as x squared over 5 squared plus y squared over 5 squared. So I have a circle, and they said it's a sphere, so it must be rotated. And what am I fitting inside the sphere?
Cylinder.
Cylinder. Cylinder, okay. So if I was to go ahead and graph this, we're just reviewing circles and ellipses right now. If I was to graph this figure, let me undo that real fast. Okay, wouldn't I go up 5, down 5, right 5, left 5?
Yes.
And I think, didn't they even give me a picture for this one? Okay, so we have our it's gonna be a little skewed because I think I have my units a little bit off, but that's all right. Bless me.
Let's see.
Okay, so I have my down 5, right 5, left 5. My little circle's a little hairy, but that's okay. But it does look nice. See, he's like sticking out. Somebody didn't brush their hair. Okay. He's spinning He's a sphere. Do they say whether the cylinder is vertically oriented or horizontally oriented? Like, is the top and bottom of the can this way or is it this way?
It's up and down, so.
Up and down? Okay. So now I have a cylinder fit inside. Now guys, remember, you can have skinny cylinders. So the vertices just need to hit the circle. You can have skinny cylinders that are fit inside. It's like tall cylinders. You can have like really, 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 really wide and short cylinders fit inside. There's all sorts of different cylinders that you could fit inside, but just for sake of illustration, I'm gonna make one kind in the middle, because I think they're probably asking for the maximum, right? The maximum volume.
Yes.
Alright, so I have my cylinder inside. Question, what's the volume formula for a cylinder?
Pi r squared
H.
times the height.
Good. So I'm trying to plug in or figure out stuff to do with pi r squared, area of the base, times the height. Problem is, I don't want r's and I don't want h's. I want x's and y's. So question, based on the graph, if I was to mark this vertex as x and y with, ready, wait, watch, x being the distance from the center over, because that's what x always is, distance from the center over, and with y being the distance from the center up, right? X is the center over, y is the center up. To the point where if it helps a little bit, I like to think about it like this, the distance up, like we were kind of doing with polar and different things earlier. We haven't done polar yet, sorry, with what are we doing with this? Radians, vectors, we're doing all sorts of stuff, go over the x and up the y. Question, how can we use x and y to fill in stuff like r and h? Any ideas?
Well, we can use x as r, and then 2y as height, so we have to
Good, because r, isn't it just gonna be half the distance across? So isn't r the same thing as x? And then height, what's height the same thing as? 2 of the y's, good. Because for the height, I need the entire distance, and for the radius, I just needed half the distance. So therefore, I can say, based upon r is equal to x, and h is equal to 2y. Because I have the distance up, which is normal y, and the distance down. So I have to double it, because distance up was only half. And then r equals x, I only wanted half anyway. So I can come back over here and I can say, okay, cool, v is equal to pi times, plug it in, x squared times 2y. Which is good and all, but I have too many variables. Does anyone remember what we're supposed to do when we have too many variables? No one? Go look for the clue that tells you the relationship about them.
Solve for y.
Yeah, exactly, good job, Luke. Solve for y. Y is gonna equal plus or minus square root of 25 minus x squared. But do you think I want the dimensions of this cylinder to be a negative number?
No.
So I'm just gonna use the positive square root. I don't want negative numbers for my radius and height and all that jazz. So I'm gonna go ahead and say, sweet, I figured out who you are, let's go plug and chug. So v is equal to 2 pi x squared, square root of 25 minus x squared. What do I wanna find for this expression?
The value of x and the value of y.
That makes it a maximum. According to the problem, you wanna find the maximum cylinder that fits within. Maximum, how do we do that? It's not a parabola. Nope, it's not, but I have a
Oh boy.
calculator.
Oh, what is that?
It's like we showed in our notes on Friday. How did we find the maximum of this guy? Plug it in. So I went ahead and took my equation, I said y equals a of x, I put in the equation, I graphed it, and I used my calculator's maximum feature to help me out. So I'm going to do the exact same thing here. I'm going to take the function. I'm trying to find the maximum of. I'm going to plug him into my nifty-difty calculator and call it, let's put it this way. So I'm graphing volume as a function of x. I'm trying to find the maximum. I'm going to approximate over here, but we'll go ahead and show it over here. There we go. 2 times pi times x squared, all times the square root of 25 minus x squared. Graph it and say, yay, it fits. Although, no, it doesn't. Well, that's a lame graph.
Huh.
Huh. Zoom fit?
Gotta
Zoom out? We're going to try zoom fit? What? It's an M! Hey kiddos, I'm going to go find a maximum. Guess which one I'm going to find? The one on the right that's positive or the one that's on the left that's negative? Positive. We want the positive one. Whoever said that said it kind of funny and I just kept going with it. On the left? Oh no, I went too far. That didn't help. Okay, go on the left. Go on the right. Was I not on the left far enough? Okay, left. Oh, that was right. Okay, cool. Just for sake for having it in my notes, I'm going to go ahead and do like a little, if I can graph it. Trying to find the maximum, and the maximum is 4.08, I'll just round it 2, and 302.299. That's what's kind of round, huh? 300. So I'm going to say that this cylinder is going to have a maximum, let's see if you guys can track, volume of, at, what am I going to say? Because y equals volume, right? So 302.2, nope, 0.300, I forgot we rounded. At x equals, who was x again?
4.082484.
But who is he?
He's the radius.
He's the radius. So I'll say r equals, so there's not room.
4.08.
R equals 4.082. Someone asked me at the beginning of class, so this type of problem, these end ones are nasty. There's only going to be one. I'm going to clearly state for you the steps that you should try to do. Like, graph a picture. Fill in a formula. Find the max on your calculator. I'll tell you what to do. You guys just need to be able to set it up. Cool, kids. With that, I don't have the answers on the normal homework sheet because I just needed to work them out for you guys since they're not in our book. Test review was so stinking long and awful.
You cut it
It's
down?
not that bad. Some people already actually, they got stuck on the homework, so they worked on the review instead. Melanie, how bad was it?
It wasn't that bad.
Wasn't that bad?
There's like 2, but that was because I didn't understand homework, so it's not.
So what do you guys look at the test review? Hold on, let's talk about tomorrow real fast. Still 6 or 7 minutes. You are allowed to use your brain tomorrow.
Oh. Oh.
Half of a 4 by
Not
6?
formula card.
Half of a 4 by 6?
Huh?
A 3 by 2 card?
A 3 by 2.
I'll take it.
I just need a strip. A 1 by 1.
Yeah.
Just like a strip. That would be.
How about the
Would you
front
like-
side?
One
Just
line.
put
It's like a communal,
Por favor.
like everyone.
Yeah, everyone has.
Everyone bring a form.
Read formula and just like throw it in
The
the,
formula
throw it in the
problem.
back.
Or you go to that and you pull out one and that's the one you get.
No, it's not.
Well, if we don't use cards, then we can use the test and group.
What else?
So guys, listen, tonight, here's what you should study. Do the work on the review using your notes. Work on the review using your notes. Tomorrow, the only thing that you're gonna be able to use your calculator on is that last inscribed problem. So once you get down to that problem, basically just raise your hand and be like, because you're on the problem, I'll let you pull up your calculator for that one, then put it down. We're not gonna do like this whole separate thing, which would be awkward, and then you don't know how much time to spend. So we'll just leave calculators under the desk except for that one, the final inscribed problem. We can pull it up and then quickly punch in and then put it down. Study your formulas, you need to be able to graph. Ellipses, parabolas, hyperbola. Isn't there an m equals tangent theta formula? Yeah, an m equals tangent theta formula. Ooh, and that angle between. So don't forget 10-1. He wasn't bad, but at the same time, you might want to go back and review. What are some weird things about all of our shapes? How to graph them. From clues or from an equation. Ooh, completing square might show up once or twice to make the nice equation fun. Foci, directrices, or a focus, like for a parabola it only has one focus and directrix. For ellipses they have vertices, for hyperbola they have asymptotes. So, work on this review. As you work on the review, think about what you're using from your notes and star those things as you're going through and just study those for tomorrow. Have your calculator, but we're starting with it under the desk. I'm going to go ahead and pass out test correction sheets and tests.
We're getting a test.
You're getting yes, right. As you guys finish. So if I were you, if you have not yet, write down the test review. It's not super long.